Hello everyone. Today I'm going to explain you about some discrete probability, and here is the question. Let's read the question first. A box contains 3 coins. 2 are regular and 1 fake two-headed coin, which means that probability heads is equals to 1. And the questions, we have two questions. First one, you pick a coin at random and toss it. What is the probability that it lands heads up? First of all, we have 3 coins in a box. So I'm going to draw something like that. All right. Let's say this one is C1. This one C2, and this one is C3, coin 1, coin 2, and coin 3. And we have 3 coins, so the probability that the coin 1 chosen is 1 over 3, and also others are equal probabilities. And the first coin has two probabilities. One is heads and one is tail, and equal probabilities they have. They are 0.5, and second one is also the same, 0.5, 0.5 heads and tails. And the last one is a fake one, H with probability 1. After we did this model, it asks us to probability heads, and it's equals to, we have 3 coins and we have everyone has the probability heads, so we can write it as probability H given C1 times probability C1 plus probability heads given C2 times probability C2 times probability H given C3 times probability C3. And also this one called law of total probability. So when we look here, it's the C1 given heads, so we look C1 coin 1, and the probability that H is equal to 1 over 2 times C1, the probability of C1 is 1 over 3 plus heads given coin 2, it's 0.5, so it's again 1 over 2 times probability coin 2 is 1 over 3 plus again heads given coin 3 is, it's always heads, so it's 1 times probability coin 3, it's 1 over 3. So when we sum them up, it is equals to 2 over 3. And the second question, you pick a coin at random and toss it and get heads. What's the probability that it is the two-headed coin? So we know it is head, and it asks us what's the probability that it is two-headed coin. So it is actually asked us probability that C3 given H, because we know C3 is the two-headed coin, and we already know H we get. So we use Bayes theorem to solve this question, and I'm gonna write it as H has given C3 times probability C3 over probability hats. So when we look at here, it is the same as we did in the first part here. So I'm going to write it directly. It's 1 times 1 over 3 over probability hats. It is the total probability of H hats comes. So it is, we already calculated. So I'm going to write it directly. So when we did the calculations, it is 1 over 2. Thank you for listening.